In this video, I'm going to demonstrate how we can take a linear equation and write it in standard form. Writing it in standard form is helpful because once we do that, we can identify the ABCs. And using the ABCs, we can identify and describe what type of graph this will look like without having to graph it at all. So, if you remember, standard form is AX plus BY equal to C. Notice A, B, and C are in capitals. These are all coefficients. Well, A and B are coefficients, C is a constant, but all three of them are just numbers, constants. So, in the very first problem, we can look at this and go and identify the fact that this is not in standard form. And the reason I know this is because the x term is all by itself, and then the y term in our c is off to the side. And notice in our standard form, the x and y term need to be on the same side, and a constant needs to be on the other side. So based on this, it looks like I need to move 2y to the left. So here's our problem. I'm going to rewrite it again so I don't mess up the original. I'm going to move 2y by using my inverse operation. So since it's positive, I'm going to subtract. This cancels itself out. Now, I can't actually combine these. So this is an expression. X minus 2y equal to 4. This is now in standard form because I have an x term, a y term on the same side, and some constant off to the other. I now can identify my ABCs. In this case, the coefficient in front of x is a, which is 1. The coefficient in front of y, which is b, is negative 2. And our c is 4. Since a and b are both not 0, then that means our line is going to be non-horizontal or non-vertical. So we can just say it's going to be diagonal. Now let's move on to number 2. Is this in standard form? No, it's not, because this time the y term is by itself and the x term is on the other side. But we will get to this form eventually. This is actually called slope-intercept form. But right now we're just worried about standard form. So let's go ahead and write this in standard form. So I rewrote my problem. So this time I'm going to want to move the 5x term to the left. So when I do that, I have to use my inverse operations. This is a positive 5x, so I'm going to subtract this. This is 0, and again I'm going to subtract this. And again, this is an expression. I cannot combine these. This says y minus 5x, so I need to write it that way. Now, technically this is still not in standard form. My x term is supposed to come first. So this is y minus 5x. So if I rearrange these, this is negative 5x plus y. Now I am in standard form and I can identify my A, B, C's. So this time the coefficient in front of x, which is a, is a negative 5. My coefficient in front of y is 1, which is b, and our c is negative 9. And again, since a and b are not 0, this is non-vertical, non-horizontal, therefore it is diagonal. Now let's go ahead and look at our last one here. This problem is different completely compared to the previous two. And the thing you must notice is which term is missing. The y term is missing. It doesn't mean it's not a linear equation because it doesn't have an exponent greater than 1. This isn't a power. This isn't in the denominator, all those things. This is still a linear equation, but it's going to be a special kind. So if I rewrite this with a y term, well, how are we going to do that? Well, if the y term's not there, that means it must have a coefficient of 0. Look at how I'm going to write this. X plus, because this is the same, now my y term is missing, so if we think of this as 0 times y equal to 2. This is saying the same thing because anything times 0 is 0 and it goes away. The reason I would do this is so it helps reminds me on how to find my ABCs, because what can sometimes happen is if we only see one term, we're just assuming b must be 1 or a must be 1 for the term missing, and that's not true. So in this case, a is 1, b is 0, and c is 2. Now this is a special case. Since b is 0, but a is not, we're going to have a vertical line. So this is how we write linear equations in standard form.